Hello everyone, this is just, I'm going to make it into an instructable. There's a competition for a rainbow coloured theme type thing using, what was it, red, orange, yellow, green, blue and purple. So let's go for it. I'm just going to use this Arduino Uno, and I'm going to use an TFT screen shield. This one's by MCU Friend. It's a 2.4 TFT LCD shield. It's got an SD card, but I'm not using that. It's got a touch screen. It's very important. It has a touch screen because that's what we're going to use. Let's just give it a wipe. Fingerprints everywhere. Oh well, can't get rid of them anyways. Okay, and what we've got is the screen is actually a bit smaller than the touch screen. The touch screen's a bit bigger than the actual screen. It's got these 5 buttons at the bottom. I'm going to use this home one for playing the game, and these N2 is for setting the level of the game, which is from 1 to 100. If anybody can get to level 100, they've got a memory that's brilliant. Anybody can remember 100, a sequence of 100 colours? I don't know. I can do it. I'm lucky to get to 4 because I'm dyslexic. Basically, I've got no short-term memory, so I forget really easy. I even forget what I'm talking about. So, anyways, it's these two pieces. We just stick them together. Should I get my glasses? Right. So that's it. That's all it is. We just stick that together like that, and we plug it in. So place that there. So there we are. Let's just reset it again. Let me just see the all come together. There we go. Draws a little rainbow, puts my logo. We can change that if you like, and it says Tim Says. Basically, it's Simon Says, but with 6 colours. Simon Says only uses 4 colours, so Tim Says 6 colours. We've got a level here. There, it's on level 3, so that means it's going to show a sequence of 3 colours, and you've got to remember them, and then you play them back on these buttons here. We've got, like I said, this button here. This will increase the level. So if you want to do, say, 10, if we stick it up to 10, level 10, it'll show a sequence of 10 colours, and then you've got to remember and copy it using these buttons. It'll go down as far as 1, so we can take it right down. I'm going the wrong way. Hang on. So we can go all the way down to 1. So that'll just show 1 colour, and you've got to remember it. Right. Well, I can do 1 colour. I can do 2, and I can do 3, and I struggle with 4. But that's because I've got no short-term memory. But yeah, I don't know if you noticed with my videos. I forget what I'm saying basically. Where was I? Oh yeah, right. So let's give it a go then, shall we? I'll go 1 to 4 and see how we do basically. Where's my glasses? Right. So we'll try 1, and so you press this button to start, and there we go, blue. So let's press blue. Yeah, and we get a tick. just so you know, it knows that if you're wrong. So let's try again. So it's a blue again. Let's try yellow, and then you get a cross. So obviously that's how it works. If you get green tick, you've won. If you get a red cross, you've lost. Let's try again. We've got yellow. There we go. Not very good at picking. Oh, we've got a red this time, so I've got a red. Yeah. So let's increase it to 2. So this time you'll get 2 colours. Green and blue. There we go. Might as well go straight on to 3 colours. So take it up 1. So we've got on level 3. That's 3 colours. So that's pretty straightforward. Whatever number there is there, that's how many colours you've got to remember. So green, green, yellow. Oh, what did I do wrong there? Right, the screen's a bit. This I've tried to put some code in there because the screen tends to run very fast. I wonder if I should put a delay in. Maybe, I don't know. Anyways, I've forgotten what that was, so let's try again. Purple, yellow, green. Purple, yellow. Shit, I pressed it twice. My hand's shaking. Sorry. Right. Yellow, blue, purple. Yellow, blue, purple. Yep, there we go. I got it this time. Let's try one more. There we go. One more. Yeah, there we go. Anyway, you get the gist of it. So let's see what the code's like and see what I did to write it. And I'll show you things that we can change as well. What we'll do is I'm using OBS now, so but I still prefer to view my main desktop. So we'll go back to that. Sure, let's have a look. Right, I'll turn that one off. We'll leave that up there so we can see it and refer to it if I ever talk about it. And we'll look at we'll look at the actual code. So let's just. Sorry, my nose is just stuffed up. Yes, so this is the code. It's Arduino code, and anybody that watches my videos will know that I prefer to use Visual Studio to do my coding, and to achieve that, and so it knows, like I say, there's red stuff here, because it doesn't know Arduino, so I can add a little bit of Arduino to it, so it knows. It gets rid of most of the not that one, but it gets like the string. It knows what a string is now. So, but anyways, we can use it. So I've laid it out. Tried to lay it out quite simple, so it's easy for you to follow and change things if you like to change things. So I ignore that, and so we've got debug and calibrate. Debug, basically, that all that does is, if we go to tools and serial monitor, let's bring that serial monitor over here. Let's clear that, and I'll reset the thing. Now, why didn't it show my... I'll restart that and try again. Oh, there we go. Right, it's connected this time. So you'll notice that it's checking for an LCD driver, and it's found this driver for this screen. This means that hopefully if you get a different shield with a different LCD on, there is a good chance it'll work, because what it does when it boots up, it actually runs this routine down here. Let's go to setup. It actually runs this routine here. So when we begin our display, I'm using Adafruit, by the way. You can visit Adafruit here. I always put credits in where credits due. Anybody who writes code and uses libraries, you should give a link to the libraries you're using so that we get the right ones. There's loads, but anyway, it's all Adafruit on this, so say thank you to Adafruit. So yeah, I'm using these 3 libraries, and with them 3 libraries, when we go to setup, what am I looking at here? When we go to setup here, and we begin our display, and I've called it my display, I run this method, and we can take a look at that. So let's have a look, and we can see that this method, it basically checks to see if we've got this driver, this driver, this driver, this driver, or this driver. So if you've got a screen with uses one of these drivers, you've got a good chance this program will work for you. Okay, so yes, so that's why that's come up. It's found the driver. Where are we? Yet, so I've split it all up. So we've got our touch screen. This is all our touch screen stuff. Oh yeah, that's what I was saying. Debug, yeah. So when we've got in debug, what that does is when I touch on the screen here, anywhere's on the screen, basically it comes up with the X and Y coordinates of your touch. So you can do this for debugging purposes. See where you want. Say I wanted to put a circle here. I can press that, and then I can see, well, right, I want to put it at 161 and 91. I usually round them up to the nearest 10. But anyways, that's what debug does. Calibrate is, oh yes, and these values are, Z is pressure, and your X and Y are X and Y of the screen. They've been mapped to the screen. So if this, like this screen is a, where are we? It's a 320 by 240. So if we go top right, this is a low number here, and it's going to be, yeah, so we've got like 1 and 9 down in this corner. If we go to this end of the screen, we're going to get close to this 320 by 240. There we go. Well, a bit lower. There we go. Yeah, no, well, actually go a bit further out. There we go. 320 by 240. So we're getting close anyway. So it's in debug mode. These numbers are mapped to the screen. But to do that, we need to calibrate the screen, and so we've got this calibrate here. So what we would do is we would uncomment calibrate, upload it to your machine, and then these numbers would then, well, let's do that, shall we? Well, you notice what them numbers were, weren't they? So we're down to sort of 0, 0 here, and we're sort of like, what was it? I'm telling my memory. Yeah, 320 by 240 here. So that's actual screen, but you can see that the touch screen is actually bigger than the screen, and the actual values you're going to get from here are resistive values from the resistive screen, and so they're not going to be. It's not going to start at 0 0 and end at what was it? Yeah, 220 by 240. It's not going to end at them numbers. It's going to be a low number up here and a high number up here, but what them numbers are, we don't know. We need to find them. So that's why we go to calibrate, and then what we'll do is we'll just upload that. Just clear that. There we go. So we've rebooted now, and because we've got calibrate defined. I don't get that colour right there. Oh, why is it not doing that? Anyways, because now we've got calibrate done. The values are now the raw touchscreen coordinates. So if I go to the top left here, why is that? No, don't tell me I have to start video again. These should be raw figures. Let me just have a look. What I've done wrong. I've moved things. Why is that lit up? Did I save? No, I didn't save, did I? All right, let's try again, shall we? All right, hang on. I forgot to save, I think. Oh dear. Oh, and I've got and I've got that in. So let me just check that out. Jesus. Right, now let's save again now, and try again. There we go. Yeah. This is just this here is just to let Visual Studio know what Arduino things are. Right, I'll reset that as well. Okay, so we've got it restarted. Right, now then I can start talking sense. So we need to get these min and max. These are actually raw numbers. These here are the raw numbers. So we've got to fill these in. So when we're in calibrate mode and we go this top left now, there you can see this is 148 by 135 top left. Before it used to be we're nearly 0. We should be 0 in that time. And if we go down to this bottom right here now, you can see we're in the 800s. So these are actually the raw values of the touch screen, and what we have to do is get these raw values and map them to the actual screen. So this is where in calibrate mode what we do is we go to find our minimums, and we put our minimums in here, and then we put our maximums in there, and this max. So we've got the max Y screen as well. So we've got the max Y screen. The screen only comes down to here, so the Y stops at this for the max Y, and then for the actual max Y. So we've got a max Y there, which is right down at the bottom here below, past the screen, and then we've got a max Y at screen, which is here. So these two numbers are slightly different. Leave the pressures as they are. This is pretty relevant, but the pressures are the Z values. So let's get this back into its proper mode, because all these buttons won't work while we're in calibrate mode. The calibrate mode is just to get these values here and fill this lot in, basically. So once you've done that, we no longer need that calibrate mode, and that should always be commented out. This can be commented out or not. It's your choice whether you want things to pop up here. It's just to help you in the debug mode. So this time I will click save and then we'll re-upload that to the Arduino. Yeah, I can't quite get it. I don't know why it's not going in focus. That, but yeah, it seems to have a mind of its own sometimes. Where are we? There we go. Sorry about that. Okay, so that's the touchscreen sorted. That's all you need to do with the touchscreen stuff, and obviously the sense pin and everything. There will be. It uses digital 6, analog 2, and analog 1. Depending on your shield, you may have to change these. And also you may have to like I say, swap these around depending on your orientation of the touch screen. Okay, so there we go. This is for storing our last point. This is because when you're actually touching the screen, it constantly reads and it constantly brings feedback. But when we're actually playing the game, I only want one reading from these buttons, and that's it. Otherwise, you see, it made some errors when I sort of touched it twice. If you touch it twice, it thinks you've touched another button. So we need to make it only see one touch at a time. I don't think it's really designed for this sort of mechanism. The display, I think this is just to do with the I've left them in they're to do with the SD card, sort of. What have you? Oh no, because it's here, isn't it? No, yeah, it's the actual LCD itself, right? Okay, and colours, right? So we've got our black and white. Well, we need black and white. It's always black and white. We always have them. And then hang on, I'm just checking something. Yes. Yes, and for the competition, well, a rainbow, that's for the students. Well, it says if you can put a rainbow. Well, I've got a rainbow going all the way around it. Yeah, and you can have circular rainbows if you're in the right place at the right time. Right, where are we? Oh yeah, and we need the red, orange, yellow, green, blue and purple. So these aren't actually, well, I'll come to that. Right, so these are actually 16-bit hexadecimal values. So that's what these are defined as, and I put them all into a 16-bit. You'll find that some of my code is C and some of it is C, C+, and Arduino. I've put Arduino code in where I'm lazy, and the rest is C and C++. So like this is C and C++. In Arduino, this would have been a short. So if you're used to using Arduino and you only know Arduino, that is actually a short. Is that? But it's 2 bytes there. You can see that it's the short. That's what it is. In Arduino, you can actually write short. So if I change that, I can go short there, you see, and it's the same thing. Where right there we go. Yes, but the thing is, I do a lot of lower level programming. Where are we? Right, yes. So I put all those colours into an array so that I can pick them out. This here is just tells me the number of colours I put in there. So if you want to add another colour, you don't have to alter any values, because the number of colours is worked out from how many colours you've stuck in there. So you can just add another colour if you like. And also the title. The title is actual characters, so you can put the characters in there as well. You can change it from Tim Says to whatever your name is, or whatever, if you want, and just change the values here. But they go in as actual characters there in that array. Then the buttons, these 6 buttons here, which we use for playing the game. I'm an object-oriented type of guy, so I've made an object of them buttons, and so we've got a round button. So the round button is an object that has an X and Y position, it has a radius, and it has a colour, and it has a name. That's an Arduino thing. If I turn Arduino on, hang on, where are we? Yeah, so if I bring that back again there, you can see that Visual Studio now knows Arduino, and you can see that it now knows what a string is. String is an Arduino thing, but I'll leave that up there because I know what's what. So I know the reason for that red line underneath there, because it's an Arduino string, and at the moment now it doesn't know what Arduino stuff is. So anyways, I'm rambling again. Yeah, so I've made an object of a button so that I can easily well, it's all to do with buttons, is this program, so that we can define our red button, orange button, yellow button, green button, and blue button, and purple button. That and that are not the same thing. That is a 16-bit. It expands to that there, which is a hexadecimal value, like I said before. It is this value, and this here is actually a string. It's a constant character string of orange there, so that's what that is. Basically, that there, this is similar to this here, but called orange or blue. I could have wrote Tim Says like this, but the reason I've wrote it like this in here is because I want different colours for each letter, like I've done up there. And what I do is I call every time I call a character, I change the colour, and then you get the rainbow effect. Oh, did I mention this is going to be a long video and I'm going to ramble on a bit? Anyways, I should have said that at the start. Anyways, let's continue. Anyway, well, actually, with the video, you've got the you've got the bar at the bottom, so you can click on the bar and just whiz through as you please and find the interesting bits. Right, where was I? Yeah, so I've done the buttons. Max level of the game, 100. Yeah, like I say, if somebody can remember 100 colours, well, anybody's memory is better than mine, because, like I say, I've got no short-term memory. Yeah, and we start at the current level of 3, but you can change that level with the buttons. Player count. This just keeps track of what you've pressed, so that is just to keep track of as you're playing. This stores all the generated. So when we start a game, we generate 100 colours. a sequence of random 100 colours, and that's where we put it. And as the player plays, the player's colours are stored in this, and then we compare the two. And if they're both the same, you win. If they're not the same, you lose. So that's as simple as that. That's how simple the game is. Basically, you generate numbers, and the player puts those numbers in, and you just compare the two. And if they're both the same, you win. If they're not, you don't. So, anyways, right. So the logo. This is my logo, right? So this is my logo. It's black and white. So it's either like a black or it's not. They're all made of bits, in bytes, and so it's either on or off. But you can see I've made a nice fancy. A fancy rainbow effect on the actual image. This is my image here, but you can see there's no colour stuff here. It's all black and white. To use this, what I do, I have my program. So let me just check that out. Put this over something. Yeah, there we go. So this is how I create images. So basically, if we load, you can see there. It's just a PNG, just a normal PNG file, black and white PNG. If we open it, there it is. It's just a ping file, nothing special. So if we open that up and we bring it into my little application, you can zoom in. You can zoom full height, full width, actual size, and then you got times 30, times 60, or you can use your mouse to zoom in and out as well. So basically we zoom right out, there we go, and it can move around. So basically you can do things with this image. If we zoom in a bit more until we get to pixels, when you zoom right in, it'll show you the actual pixels. And if you choose black, you can add something to it. There you go. So there we go. Added something to it. Zoom in, and if we use transparent, we can get rid of something. And then you can save that image as whatever you want. You could save it as any of these. You can save it a bitmap, Windows Metafile, EMF, on TIFF, or GIF, even JPEG. Then you can just save it. So I'll cancel that. There we go. So once you're happy with your image and you've edited it, or you've got your own image and you've changed it, I've made this to fit in there nicely. You might as well keep it the same size. So I've made that image 128 by 128. To create a new image, all you'd have to do is you can just go 128 in there, 128 in there, and then create new. And then you've got a clean slate, and you can start from scratch and draw what you like there, basically. Just do anything. So I'll just load the other one back in again. Yeah, so you can see here what the size is here, and you can see the format it is, but that doesn't really matter. This is just info. But what we want is because this is a TFT screen, a coloured screen, the image is drawn top left, and it goes bit by bit along the first row, and then the next row of bits, and then so we want the single bit ordered indexed checked here. This vertical bit, orthodox bit, basically what this does, it does the 8 bits from the top. It goes 8 bits down, and then the next 8 bits down, and the next 8 bits down. That is for sort of like when you're using sort of screens like this, which are just monochrome stuff. These use a different format to save your images. It's all a memory thing to do with memory of the drivers inside. So anyway, once we've got this image, I told you I was rambling. We can convert it to hexadecimal. So I want it in hexadecimal. You can have it in binary if you like, or you can have it in decimal. But hexadecimal is the way we do it, and the bit size is 8-bit. So we'll just get. Oh, this 32 means. Hang on, let's have a look at my code. You see my code here. You see. Well, each row consists of like that. See how long a row is. That's what this is. It means there's going to be 32 bytes. That's all it is. It doesn't really matter what this number is. It's just when you put it into your code, it looks all right. So you just go and click Get Data, and then it just reads through all this image, blah, 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 all the way down until it gets to the end. It's a big image. It's 128 by 128, so there's quite a lot of bits and bytes. So then once you've got the data, you just copy all, and then you just come in here, and then you can just change that and paste it in. Since it's the same image, I'll just paste it in. There we go. Oh, except hang about. Where are we? I think I've made it. Oh yeah, I think I had it longer before. But anyway, that's it. You just put it all in there. I'll just undo that. I think we're there. Yeah. Let me just put that. I don't like it like that. Let me just set that one in one there. That looks better. Right. So save it again. Right. Yeah. So there's my image, and that's what that one is. These other two, one's my tick, and one's my cross. So tick. I've got a tick for win, and I've created a cross for fail. And those were just if we just go to load. That was these two images here. I just made them images. So if we just open that in, there we go. We've got our tick. Let's just go full width. There you can see it. Oh, try full height. There we go. That's better. So there's my tick, and then you just get the data. That was a lot quicker. It's a smaller thing. That's only 40 by 40 of those. And then you copy all them, and then you just paste it in there. So that is if you want to change the tick. You might want to put a smiley in there, create a smiley, have a grinning smiley for a win, and then a sad smiley for a lose, anything like that. So the choice is yours. Just make those the same size. 40-40, I think it was, wasn't it? I should have thought, I usually write 40-40 there. Anyways. So that's them. So where was I up to? I'm just scrolling down now. Yeah, max level. So our setup, yeah. Right, yeah, this is where the display chooses your thing. Did I do that or didn't I? I can't remember. I can't remember. Right, okay, I'm going to do it again just in case. So let's look at this definition. Right, so well, it's a method actually, is that? So this method here, it actually checks your shield to see what driver the TF screen is using. So basically, if you haven't got this screen, there's a chance it'll still work if your screen uses this driver, this driver, this driver, this driver, or this driver. So you've got a good chance that the program works, because what it does here, when we create an instance of our display and begin, it checks to see which driver to use, and that's what it does. all thanks to Adafruit. Yep, so we just fill the screen with thing, and then we draw our round rectangles. Right, yeah, so Adafruit's library, when you draw a rectangle, it just uses 1 pixel thick line. So I've done a method for that as well. So if we look at that method, you can see I've put a loop in here, and this loop, it loops each colour 4 times, so you get this thicker line. So we get a rectangle with 4 pixels thick, and then each time it does a loop, I change the colour as well, and we're using this size of colours. So if you add another colour, what it'll do, it will put another colour in there. So yeah, that's that straightforward. And then we draw our logo. So this bit is the bit that's actually drawing our logo that we did here. And then we draw a title. This draws our title that we've put here. Title. Where are we? Title. So, we clear button out. It just, I put that there just to make sure it was clear before we draw them buttons, and then we just draw the buttons. That just draws all these 6 buttons here. That method there uses another method. So if we look at that method, oh well, you can see it down here. Look. So I'm just going. So basically, if you add another coloured button in there, it will do loop for the size of buttons and draw the buttons, and it'll draw buttons 1 through to whatever number of colours you've done, which it draws a button here. And this is just using Adafruit's library, just drawing a filled circle. And our button, and it uses the button which is in our, where are we? There, I've created an array of buttons, so it uses all the array of buttons. Actually, that there should be, where are we? Where did we get to? Oh yeah, size. That should be size of buttons. That should be there. If you add another button, not colours, buttons. There we go. Save. Yeah. That's because I copy stuff. Okay. So yeah, so it'll draw so for the number of buttons we've got in our button array, it will draw them buttons, and it uses this to draw the buttons, which is just basically this button position. Because the button is an object, that button has an X, it has a Y, it has a radius, and it has a colour. Okay, so there we go. That's that. Yes. Right. So yeah, and basically, all right. Where was that? Draw buttons and print level. All right. Yeah, that just prints the level up there. Basically, just prints this bit of text and the level it currently is. So that's it. So we're all set up and ready to go. So we've got our loop now. And basically all this does, it listens for you touching the screen. So as we touch the screen like this, what it does here, well actually it sends the sense pin high to actually sense if there is a touch, because it wants to get a voltage reading back basically. So it sends the send pins high, checks to see the resistance on the touchscreen pins, which is an instance. So it creates this touch point, which is an instance of Adafruit's library touchscreen point. Yes, and then once it's got that, once it's created that instance, basically, that instance has values like it has an X, Y, and Z. It's very similar to my buttons. It then turns the sense pin off and puts these 2 pin modes to output. Yes. So once we've got that instance of touch point there, basically what we have, if there's this is Z is the pressure. So if the pressure is above the minimum pressure, so if there's nothing touching this, it won't be above the minimum pressure. But if something's touching, it'll be above that minimum pressure, and it's going to be below the maximum pressure, because we've actually set the maximum pressure at the max anyway. We've set that at 1000 there. I'm not really bothered, because if there's something touching it, I want to know. Where are we? Yeah, it will go and do the touch check. And now this is another method, and it's quite a complex method, but we'll come back to that in a moment. So once I get down to it, we'll look at that. So basically, it sends a copy of that instance to this method, and then that method will then do what it does depending on what that method, what that instance is values are. And then we continue, and this is to do with the touch screen. It doesn't really work well as a button. You can't have 2 states, on and off. It's either on, well, it's either giving values, constantly giving values. When it's on, it's constantly giving you values of X and Y. It doesn't stop giving you constant values of X and Y. It doesn't like say, yes, you've touched me, and it doesn't say like, no, you haven't touched me. What it does, it gives a constant reading. So what I need to do is to put some method in for it to just, for us to ignore all but the first reading it reads once you touch that screen, if you get my meaning. When we touch one of these buttons here, we just want the first touch. We don't want a continuous reading of all the position of the stylus on the screen. We just want the first one. And so what I need to do is I need to know once we've released the screen, and so once our pressure is below this off pressure, then it sets the value in Y of the point to 0. So then that way we know that we're not actually touching the screen. I'll come back to that a little bit later as well. But anyway, basically it's just a repeat of that. It just keeps checking checking to see if we've touched something or we haven't touched something. So we'll go to this now. So this is the important bit. So go to definition. So if we go to our touch screen here, so we've got an instance of the current touched point, and if this is a definition here to say if we're not calibrating, then we need to map that point to the screen. So this bit here is actually mapping the actual values of the current touch point to the size of the screen, so that our screen width and height, it maps all them points so that we actually get the relative screen position that we're actually touching. But like I say, if we are calibrating, then it misses this piece out. But if I was, well, this is one of the reasons I use Visual Studio. So let me just uncommon calibrate. Let's just uncomment that out. Right. So let's just save that. Say updates. So if we go back down to where we were. Yeah, you can see that this is all greyed out now. So when in calibrate mode, we don't actually map the current touch point to where we're actually touching, and so when we come to do the if we're either in debug or calibrate mode, it will actually print the raw values because we haven't done this here. So if I turn calibrate off now, there we go, save that. And we come back down here. You can see now that it's all written okay, and it's not greyed out anymore. This I can see that this is going to be used, and this is going to be used. So if I turn debug off, look. There we go. There you can see it's all greyed out basically. So hang on, this is my memory playing up again. So when we come to compile this code, the compiler will actually miss this out basically. Actually, I'll leave debugging to take it. Oh yeah, and if either of these are out as well, you can also see that I also don't. Where's setup? Here's setup. Can you see we don't need serial anymore because the both are I've turned both off. So because we're not printing anything down the serial, we don't actually need to begin serial, so we don't need all the code and memory it takes up for that. If I was to compile it now, let's just save that and compile it. I always like to put this in as well, like so you see this. This bit in, but I know it's not much because we haven't done much, but basically we've just saved about 1% there, 1% there. Basically, that's all. But I might just need them extra 25 bytes. You never know. Anyways, that just for people to know. So anyway, I'm going to put debug back. Oops. Debug back, save that, and then you can see that in setup, we've got serial back. That's an Arduino thing, so I haven't got it turned on. Anyways, I'm rambling again, so let's go down to the important bit. Right, yes, so where are we? There we go. So yeah, we come down here. So once we've got, as soon as we've touched the screen, we need to know what we need to do. Well, we need to know where we've touched the screen on here. So basically, we've either touched the screen on one of these buttons, or we've touched the screen on one of these buttons, which it could have been one of these N2 to move the logic level up or down, or it could have been this button here to start the game. So where are we? Yeah, that's all turned on. So we've got our debug on. Right, yeah, so off-screen menu stuff here. I've put that there. Hang on, let's just put a space there. Yes, so what I've done is I've split this into two sections there. So I've do my off-screen stuff here, and I do on-screen stuff here. So basically, what I'm saying here is this off-screen here is basically this menu stuff. This menu stuff down at the bottom here. This is all off-screen. The screen ends here, sort of thing, basically. So this is all off-screen. So basically everything off screen is all to do with these 5 buttons here, so we'll look at them first. So if our current touch point Y is greater than the display height, so that basically is, so this is our display height here, and then if it's greater, remember that our coordinates start here, which is 0, 0. When you're dealing with it's not like your normal plot or drawing coordinate system. This is a display system. Basically, this all started from your RT, what was it? Cathode ray tubes. CRT, that's it. CRT. This is where the CRT started. It had a little, it scanned across it, went started top left and kept moving its way down. So basically what you have, so displays have always kept the CRT XY coordinates. So just remember, when you're doing your numbers, you're starting at 0 at the top and you're coming greater as you come down, basically. Excuse me a minute, I just need to take me a few pills. I'll just pause. I am back. What was I saying? Oh yes, yes. So this is everything to do below this point. Where's my pointer again? Yes. So down, it's in this menu here. So basically, all we do is we just check to see if it's below there. I put a debug. Just say we're in the menu area. That's all that does. Let's just press that button down. Let's try that one. There you can see menu 3 there, look. So we've done a menu. And then all we have to do is divide this bottom area up into 5 areas. So that's what I've done here. Basically, if it's less than 40, x is 45, and then if x, that's this direction, so it's from left to right, basically. For this button, it's anything less than 45. For this button here, it's anything greater than 190. And then for this middle 3 buttons, we've got put it between 2 values. So that's button 2, and then it's button 3. And then we've got our plus and minus level buttons here, which basically these 2 buttons, that's this one and this one. Our level goes -1. And if we use the other one, our level goes +1. So if I press these, we can see that we're moving the menu level -1 or +1. There we go. Actually, I haven't put them in a debug sequence, but never mind. What I should have done is I should just go there, there, there. There we go. That's how it should be. So then if we're not debugging, then these won't be actually read. That's probably why the difference in memory was slightly out a bit, because I think Arduino, if you stick a serial in there, it loads the whole serial thing. Yes, so that's it. And then we've got the start button, which is where are we? This button here, this button. I'm using the start button. So basically what happens when we press the start button, our play count is set to 0, we generate a sequence, so basically that's another method. So what we do is, if we look at that, so we generate a sequence. What I'm using here is as a random seed is our millis, so depending how long your Arduino's been sat there ticking away, this millis will be a different number. So we use a different number to generate our first random seed. Basically, it's a seed is something where it picks a thing at to do. If we just didn't use a random seed, every time we turned Arduino on, the random numbers would be the same over and over and over again. So we need a random seed basically, so that our randomization starts at a different number and then continues to randomize. And then to pick a random number, we use the number of colors. We need a number that's within the range of our colors. So when we're actually well, let's have a look at that. You see our number of colours here. Basically, that is the size of the colours that we've put in here. So we're using our number. So it ensures that the random number is going to be one of these 6 colours, basically. Let's go back to where we were. Why am I not gone back? Oh, sorry. Oh, there we are. I moved it down too far. Yes. So so we have our random index, and then we use that index there to choose the colour that we want. So it adds, because this is in a loop, basically our generated sequence then gets filled with all these random colours we generate, and it fills up this array with different colours from our colours index. So this is going to pick one of the colours that are in that array. Let's close that. So once that's filled, we need to show that we need to show that what colours that we've put in that new array. So we then show the sequence, and so when we show the sequence, what we do is we clear our results. So if we'd previously done one of a game, there will be the colour that we chose, and there will either be a tick or an X above the colour. And so what that does there, that clear result is just to clear the tick or X. And then also, while it's doing the sequence, we want to clear this button area. So these 6 buttons here, these 6 colours, we don't want the user pressing these buttons while it's showing us a sequence that it's chosen. So what we do is we clear the button area. So all that does is just it overwrites the buttons with black. Basically, it colours the area in black, and it also sets a flag. If we look in here, pick definition there. All it does is draws a black rectangle over the top of these buttons so they all look black, but then it also sets show buttons as false. So this is a flag to say that these buttons are not seen, and we can use this flag later on in the sequence to check whether that the buttons are there and the user can actually press them buttons or not. Yeah, that was it. I'm lost again. I've forgotten. Yeah, show sequence. So that's all. So that's what happens when we press this button here, it runs through the sequence. Then once it's run through that sequence, we've got that flag, and it runs show sequence. Hang on, where was it? Show sequence. Yes. So we clear the area, and then so this area here, we want to, where it's been showing our sequence here up next to my image, we want to clear that area, so we just show a black image, and then we wait a little bit, just delay things, and then what we do is we redraw these. Oh yeah, yes. Sorry, I got ahead of me somewhere. Clear buttons. Oh yeah, that's right. Yeah, sorry, I got ahead of myself. Yeah. So this area where we're showing the sequence, if we'd already done a game, there will still be a colour left here, and we don't want that colour left there because we might mistake that colour for the first colour that we need to press. So what we need to do is we need to put a black colour there. So what we do is we put the black colour, and then we do the sequence of colours that the Arduino has generated, and then we redraw all our buttons back in, so all these buttons come back in, and the user knows is ready to start entering the colours into the sequence. So that is that part. That was the pressing the game bar and all the menu bit at the bottom. So what we can do is go to the actual buttons. So you can see that I've got a flag here that says show buttons, and as I mentioned before, that was in the when we were generating the show sequence. We did the clear button area. So I'm going, where's our clear button area? Clear button area. We've got our show buttons flag there, you see, and we've set it to false because we're actually doing the sequence. But once we finish the sequence, we set it to true, and then alright, yeah, so we did the draw buttons. Where are we? Draw all buttons. Here we set the show buttons back to true, so we know that all the buttons are there visible for the user to see. And so because we've got them all visible, this statement here, this flag, will now allow us to do the on-screen pressing these buttons here. And so basically it's very similar to this menu. We just divide it up into the 6 buttons, and depending on which 6 buttons we send that button on and the colour on to colour select show, which shows the colour we've selected up here again on this screen, and then we keep doing that until we get it until we finish the sequence. If we get to the end of the sequence, we'll get a tick, but if we make a mistake on the way, we will get a cross. So if we look at this, when we send this colour, let's go pick that for you. Alright, no, let's just send that colour. So where was that? Button result. Oh yeah, I think this is it. Yes, so when we send our red button, so if we've clicked the red button, we send the button result to the red button to button result. Let's just hang on this. And what we do is, so for each colour we send a different colour to the button result. There you can see that for each button. So if we look at one of this definition here, what we can see is we've got our debug just to show that we've what button we've pressed, but then we have our player sequence and our current player count. So depending how many times we've pressed a button, that's our player count, and it puts it into the button which this method has received. It puts this button color into that player sequence count, and then what we do is, as I said before, we check the two arrays. So if the player sequence color is equal to the same generated color, then if it's not correct, that's it, sorry, we check to see if it's correct first. If it's not correct, we draw the false result. We put a cross above the thing and we exit and return. We clear the button area and we return. So basically we just say no, you failed. But obviously if it doesn't enter this subroutine here, basically if it is correct, then it will continue. It will increase our player count by 1. We check that the player count level is not greater than the actual level we've set up here in the level. If we've now got a player count greater than the actual level, then we've managed to succeed to that level correctly, and so we create a true tick, and then we finish the game again, basically. So, but obviously if we haven't reached the end of the level, it just keeps continuing in a complete loop until we actually get to the actual level that we've set, and give us a tick if we've done it all correct. Well, I hope I explained that all right. I'm sorry I might have rambled a bit, but I find it difficult. Where are we? I don't want that. I just want to tidy up. Oh, there we go. Yeah, there we go. That looks it. I can see what I'm looking at then. Yes. So let's just finish it off. What I will do is let's just where is it? Let's turn that on. That should be bigger than that. Oh, damn, I've done the wrong thing. Yeah, there we go, that's better. I was just trying to increase it. I wish I could get that in focus for some reason. I don't know why that is not in focus. Let me just try and do that. See, I'll flick on here. What about my hand? Hand looks alright, doesn't it? No, that's made it worse. Well, it must be just because it's a... It's because it's an LCD, I think, really, basically. I just wanted to just finish it off with another game. I'm not going to go to 6, that's for sure. Let's try another 4, shall we? Get me glasses. So, well, let's have a look. Oh, must have done something wrong there. I don't know. Try again. I've forgotten it already. I tell you, I've forgotten it. I've absolutely no short-term memory, guys. Unless it's written on the screen and I write things down, I don't remember. It comes back to me later on, but it's not instant. Let me try again. Yeah, there we go. Yeah, that was another one. One more and then we'll call it a day, because it's one very long video. I hope you've scrolled through. Gosh, I must pressed it twice now. I thought I had it. Yeah, there we go. Yeah, my hand shakes a bit, so you've got to do a quick stab on the buttons. It's just the way the LCD screen works. But anyways, if you made it all the way through, and I hope you did find something interesting. The video, I tried to explain how the code works. So for those that want to give it a go at doing some coding with one of these LCD screens, as a good start. Well, like I say, if you made it to the end, thanks very much. Even if you just scrolled all the way to the end, thanks very much. I'll call it a day at that.